Hello, ladies and gentlemen. Thank you for joining me. It's Root Beer here, and we're going to be looking at question number 2 on the 2014 Manitoba Math Contest. In triangle ABC, AB is 3, BC is 4, and AC is 5. Find the length of the altitude from B to AC. Okay, so hopefully you've done some math contests or even just done schoolwork enough to know that 3, 4, and 5 is a right angle triangle. These are a Pythagorean triple, so they form a right angle triangle. So I'd probably start off by saying that ABC is right angled 3, 4, and 5. Now we want, we got A, B, and C. Now we want an altitude here. Well, how could we figure that out? Well, let's look at the same triangle two different ways. One where the altitude is standing straight up, and one which is the first one I wrote. 3 and 4 here. So we want this length h. Well, it's a height. We have a base here. So we could say something like 1/2 h times 5 is the area of ABC. But we also have a height and a base here because it's a right angle triangle. So it's 1/2 3 times 4, or 1/2 of 12, or just 6. So rearranging, I get h is 6 times 2, 12, divided by 5. Okay, and there we go. So explain that it's right angled, otherwise you can't use this 1/2 3 times 4 thing. Alternatively, we do know it's a height h, and so if we look at, 5 is the base, h is the height, we can still get this area of a triangle. And even if we didn't recognize that 3, 4, 5 is right angled, there are other ways to get the area of a triangle. Most notably, since we're given the side lengths, Heron's formula. And I'll see if I can remember it off the top of my head, but it's worth looking up and Googling so that you can see it and see how it's derived. Now, if we let S be the semi-perimeter, so A plus B plus C over 2, and although I guess my picture looks right angled, I'm going to change that. So just sort of any triangle at all, then the area can be found. So A plus B plus C, the semi-perimeter, not that hard to work out. What is it? It's S times S minus A times S minus B times S minus C, and we square root the whole thing. So, for example, with 3, 4, 5, 3, 4, 5 adds up to 12, divided by 2 is 6. So in this case, it would be square root of 6, 6 minus 3, 6 minus 4, 6 minus 5. Okay. You will never get S minus something being negative. Try and prove that with triangle inequalities. 6 times 3 times 2 times 1, well, that's 6 times 6, so square root of 36 is just 6. And yeah, that's the area that we found. But that's another way to do it if you didn't recognize that 3, 4, 5 gives you a right angle triangle. Okay? Perfectly acceptable, and it's something to look up. It's something, I find Heron's formula doesn't come up a whole lot on contests, but sometimes in those rare instances when it does, it can be very much worth it, because you're not always presented with a right angle triangle. Okay? So that was just A part of question number 2. We do have a B part. B, this same altitude divides ABC into two smaller triangles. What is the ratio of their areas? So we'll draw a slightly bigger picture. So we have 12 over 5 here, 5, and yeah, it does indeed give us some smaller right angle, or smaller triangles. Now these ones here are also right angled. And I think for this question we do have to know that 3, 4, 5 is a right angled triangle, because looky here, if we have call this check and this x, we know check plus x is 90, but we have two smaller triangles. Well, this is going to have to be x and this is going to have to be check. So it turns out, and you should probably write a sentence of explanation here, but turns out the two smaller triangles are similar to the 3, 4, 5 triangle, ABC. Okay? So, if we compare them, and we want to compare their areas, right, what's the ratio of their areas? Well, actually, no, we don't need this information. I just got ahead of myself. Yes, it's true that these are similar, but I guess by Pythagoras, so we can ignore this. We could do the question this way with similar triangles, and the sides are in the ratio 3 to 4, so it's going to be 9 to 16. So I'm just going to say 9 to 16 is the ratio, and that would be one or two extra sentences there. But we could also just compute their areas directly, because this is going to be square root of 3 squared minus 12 over 5 squared, and this is going to be the square root of 4 squared minus 12 over 5 squared. And they're right angled triangles, so it's going to be, this base x and this base y times 12 over 5 over 2. So the areas are in the ratio 1/2 12 over 5x to 1/2 y times 12 over 5. But that's just a ratio of x to y, which is a ratio of 9 minus 144 over 5 to 16 minus 144 over 5, all square rooted, of course. 25. And that's going to be 225 minus 144 over 25 square root to, what's 16 times 25? That's 4 times 5, so 20, so 400. Okay. This is going to be 81 over 25. Square root of 81 over 25. And this one here will be square root 256 over 25. And so that's 9 over 5 to 16 over 5, which is, once again, the ratio of 9 to 16. Okay, so you could have done it with similar triangles or direct computation of the areas. Either way is fine. I shouldn't have. That was just me getting too excited about just being able to directly compute things. So I got a little space, and obviously I got a little time because I'm not actually writing this contest right now. So we'll just we'll refine this a little bit. So the triangles are similar. So I guess you could do the direct computation again if you hadn't realized that 3, 4, 5 is a right angle triangle. If you had, do the similar triangle route. So these triangles are similar. And so the ratio of the areas. All right, if sides are in the ratio of something like m to n, areas are in the ratio m squared to n squared. So this is a nice little fact. So the sides, and we can compare the hypotenuses. These are the two hypotenuses. So the sides are in the ratio, because they're similar, there's going to be a common ratio. So 3 to 4, therefore the areas are in the ratio 3 squared to 4 squared, which is just 9 to 16, which is something we directly computed earlier. Okay? If sides are in a particular ratio, areas are in the square of that ratio. Volumes are in the cube of that ratio. This is something that you may want to be familiar with. It pops up occasionally on contests. Okay? It's really easy to see if it's something like a cube, double all the length of the cube and you will increase the volume 8 times, but it's not so obvious that doubling the length of a triangle somehow makes the area 4 times bigger. But it is true. Okay? And it's something that you can look into on your own. So that's question number 2. And in the next video, we're going to take a look at question number 3. I hope to see you there.